Hello, welcome to Astronautics for Exploits. This is Dr. Ayenshola Ogundele. Deep space astronautics missions for unraveling the mysteries of the cosmos and prepare for eventual human missions to the deep space. The focus points are as follows: deep space exploration and deep space astronautics missions. Over many decades, humans' ingenuity and immense capability to design and develop rockets and spacecraft has enabled engineers to be able to launch rockets into space and send spacecraft to their mission orbits to perform various purposes. Spacecraft have been used for communication, Earth observation, navigation, scientific purposes, and to study planets. Human exploration of deep space is an ambitious goal that requires the use of deep space astronautics techniques to design highly efficient missions capable of making life easier for human explorers. Examples of deep space missions are NASA's CADRE, Cooperative Autonomous Distributed Robotic Exploration, Ingenuity Mars Helicopter, Deep Space One, Integrated System for Autonomous and Adaptive Caretaking (ISIC), Artemis program, robot dogs on the moon, Deep Space Positioning System, and a host of others. Deep Space One was a NASA technology demonstration spacecraft which flew by an asteroid and a comet. It was part of the New Millennium program dedicated to testing advanced technologies. Deep space exploration involves missions to planets, moons, and other celestial bodies in the solar system, as well as missions to explore the vastness of space beyond. NASA Deep Space Network is a global network of antennas that supports communication with spacecraft in deep space, enabling missions to explore the solar system. Artist's concept of a future moon landing carried out under NASA's newly named Artemis program is shown in this picture. Deep space astronautics missions are as follows: NASA's CADRE project, Ingenuity Mars Helicopter, Deep Space One, NASA's Amadas Artemis program, Integrated System for Autonomous and Adaptive Caretaking, Mars rovers, Curiosity and Perseverance, Valerie, robot dogs on the moon, Deep Space Positioning System, CADRE 1 and 2, OSTRIRES, and Deep Space Optical Communications. NASA's CADRE project, Cooperative Autonomous Distributed Robotic Exploration Project, is developing a network of small rovers that will work together to explore the moon in an experiment to demonstrate new technology. Communication is planned to be via mesh network radios with each other at the base station aboard a lunar lander. The rovers will be largely autonomous. The picture here illustrates CADRE, a NASA game-changing technology development. By taking simultaneous measurements from different locations, the rovers will demonstrate how multiple robots can collaboratively record data that will be impossible for simple robots to gather. The project's success could pave the way for autonomous, multi-robot missions that pursue science goals based on such distributed measurements. NASA's Cooperative Autonomous Distributed Robotic Explorer project is shown in this picture. Ingenuity Mars Helicopter is an autonomous NASA helicopter which operated on Mars from 2021 to 2024. The primary objective was to demonstrate the feasibility of powered, controlled flight on another planet, specifically Mars, and to serve as a scout for the Perseverance rover. Mars Ingenuity is illustrated in this picture. Deep Space One was a NASA technology demonstration which flew by an asteroid and a comet. The primary objective was to test and validate new high-risk technologies for future space missions. The Space One asteroid and comet mission is shown in this picture. NASA's Amadas automated a configurable mission adaptive digital system is developing software and hardware that will be able to autonomously assemble materials to make a variety of functional structures. Recently, builder robots capable of autonomously working together and assembling small modular units called VOSES to make a large variety of structures are being developed. Automated reconfigurable machine adapted digital assembly is shown in this picture. Artemis program is a moon exploration program which is intended to re-establish a human presence on the moon for the first time since the Apollo 17 mission in 1972. The long-term goal of the project is to establish a permanent base on the moon to facilitate human missions to Mars. The mission will focus on exploring the lunar South Pole. Planned mission of Artemis program is shown in this picture. Integrated System for Autonomous and Adaptive Caretaking develops autonomy software for intravehicular robots, and it delivers technologies to enable remote and autonomous caretaking of gateway during long periods of time. Integrated System for Autonomous and Adaptive Caretaking is shown in this picture. Mars rover, Curiosity and Perseverance, which are part of Mars exploration program, are robotic vehicles exploring the red planet, with Curiosity focusing on habitability and Perseverance seeking signs of past life. Self-portrait of NASA's Curiosity Mars rover is shown in this picture. Valkyrie. Robots like NASA's R5 Valkyrie could be used in future missions as precursor robots performing mission tasks before humans arrive, or as human assistant robots actively collaborating with the human crew. It was initially designed to complete the system relief materials. However, its main goal is to prove itself worthy of even through terrain. NASA's Valkyrie robot is illustrated in this picture. This space positioning system is a low-power self-contained instrument that provides the equivalent of global positioning system throughout the solar system without the aid of artificially provided infrastructure. It is able to determine the position of a spacecraft anywhere in the solar system. The picture here shows this space positioning system. Robot docks on the moon. Dock-shaped robots may be used on future moon missions, as humanity's best friend is an agile explorer already. Leaping, digging, and exploring elevated terrain are all things docks eagerly do on Earth. The robot dock concept is called LEAP, or Legged Exploration of the Arcos Plateau. LEAP, which is one docked idea to explore the moon in the future, is shown in this picture. Chandrayaan-1 and 2. Chandrayaan program, known as the Indian Lunar Exploration Program, is an ongoing series of outer space missions by the Indian Space Research Organization. There have been 3 missions, with a total of 2 orbiters, landers, and rovers each. Artist concept of the Chandrayaan-1 is shown in this picture. Chandrayaan-1, launched in October 2008, was the first Indian lunar probe, and it consisted of an orbiter and an impactor, while Chandrayaan-2 is the second lunar exploration mission, and it consists of a lunar orbiter, the Vikram lunar lander, and the Pragyan rover. Vikram lander mounted on top of orbiter is shown in this picture. OSIRIS was a NASA asteroid study and sample return mission that visited and collected samples from asteroid Bennu. OSIRIS mission is shown in this picture. This space optical communication is a laser space communication system in operation that improved communication performance 10 to 100 times. Scheme of the architecture for the planned deep space optical communication prototype is shown in this picture. For more information, contact Astronautics for exploit. You've been watching and listening to Deep Space Astronautic Missions for unraveling the mysteries of the cosmos and prepare for eventual human missions to the deep space. Presented by Dr. Anshola Ogundele, with the focus point deep space exploration and deep space astronautics mission. Thank you.